All right, boys and girls, Renee Kazishki here. Going to go over the FRQs that you did this week. First one was Monday, talking about mRNA processing in eukaryotes versus prokaryotes. So they give you some information, some numbers, and this question is worth 4 points. In format, it's very similar to how question number 2 on your test this year is going to look, because they said it would model question number 4 in previous tests. And so it's going to be 4 points. I underline in red the things you had to have to get those 4 points. So let's get going. If you don't have your FRQ response in front of you and you need it, I may have to release that form or share your answers back to you unless you wrote it down somewhere. So we'll work on that, but you're going to want to have your response available so that you can get an idea on how you did. All right, so here are the answers. Now, I included a little more information than necessary, but everything that's essential has been underlined in red. Part A, the primary transcript. Question was how to get shorter. The answer is it was processed. And I put here in the second statement, it was processed, and that processing removes introns, making it shorter. You also had to identify the location in the cell, so you have to have that's in the nucleus. For part B, the answer is 15 kilobases. Why? Because in prokaryotes, they don't use intron. They don't have them. They don't recognize them. They can't cut them out. 15 kilobases is going to be the length of that mature mRNA. There is no mature mRNA, actually. In prokaryotes, it's just mRNA, because as soon as it's made, it's ready, it's mature. So I want to mention a couple things. I included some vocab like spliceosome. That's not really necessary. Again, the necessary pieces that will earn you the 4 points have been underlined in red. You can also tell I'm trying to model a little bit more professionally the format for your answers. I'm using complete sentences, complete thoughts. I'm not restating the question. I am not using abbreviations like BC for because, or any of my other little silly symbols. And this is what you're going to want to do on the real test. So let's move on now to Tuesday's. Tuesday's question took you all the way back to Gregor Mendel and fruit flies. So Thomas Hunt Morgan as well, especially here in Cross 3. When you look at these numbers, I mean, of course you got to read the prompt, right? But when you look at these numbers, you guys are so smart, experienced. You look at this and you should see 3 to 1. 3 to 1. Roughly 3 to 1 ratio in the F2 offspring of bronze to red. Likewise, here, we're looking at wings, 3 to 1. 3 to 1. They flip the numbers like the order of the dominant recessive traits in the table, but it's still 3 to 1 ratio. You also see that male and females have roughly the same number in each phenotypic category. That's true for this one too, up there with the eye color. So from that, we know that bronze is dominant and stunted wings is dominant. And we can make the conclusion that if we were to breed in the F2 a dihybrid with both of these traits together, in other words, if we were to look at the third cross, sorry, lost my train of thought there a little bit. If we were to look at the third cross and breed true breeding bronze-eyed with stunted winged males, sorry, let me backtrack a little bit. I don't want to start this again. You guys deserve some clear answers, so let me just go straight to them. All you guys got number 1 right, bronze eyes. Number 2, use the data to justify your response. This is a little tricky because many of you put a wrong answer. Many of you put The data shows that there are more bronze-eyed babies than there are red-eyed babies. That just ain't true. I mean, it is true, but it ain't true that that's a reason why. Because it's not the number of offspring or the comparison, it's the ratio. So you either had to say all F1 offspring had bronze eyes, that's stated in the paragraph, not the data table, or you could say all the F2 offspring come out, and when they come out in a 3-to-1 ratio, bronze to red. Therefore, Mendel would say bronze are dominant. All right, cross 2, it is not sex-linked. Looking cross 2, equal number males and females in both phenotypic categories. If, and I liked, sorry, the cat's bothering me. I liked what some people said. I think it was Emily Jones. Now I can't see because the stupid cat's up here. All right, hang on. Sorry. Some of you guys said if it were sex-linked, all the F2 females would have the dominant characteristic, and they don't. 3-to-1 ratio in the female column, dominant to recessive. So different ways of explaining this, but I think this is the simplest one. When we look at the next question, you could figure out the answer by just looking at the way they lay this out. F1 flies. You know F1 flies have to be this. Heterozygote for both traits. They're crossed with true breeding red, normal wing flies. This is the standard test cross, boys and girls. This is chapter 15. Test cross is always going to be a double heterozygote with a double recessive. And we do that to see if we can find any weird ass numbers. Remember? So we go boom, 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 boom. These are your parentals. These are your recombinants. So this would be any offspring that looks like the parent with that combination of genes and therefore phenotypes. This would be any offspring that looks like this parent. And these guys would be recombinants. And we know that if these genes were on different chromosomes, they would assort independently, but they're not assorting independently because look at this. 2200 to 300 to 220 to 2180. These weird ass numbers right here, right? So then we assume that crossing over must be happening, but it's not happening that frequently. The alleles are linked on the same chromosome. The offspring don't fit the 1-1-1 ratio predicted by Mendel. And so another way of writing that, I don't want to overwhelm you, but I did on the back clarify this a little bit. It says the offspring with phenotypes that match one or the other parent are produced 90% of the time, showing that crossing over occurs only occasionally to produce the recombinant offspring. Now, you could calculate the recombination frequency. It's not necessary at all, but some overachievers may want to do something like combine these offspring, add them all up, so you'd have like the number of recombinants divided by the total. They'll give you a decimal, which is the recombination frequency. General rule of thumb is if that recombination frequency is less than 50%, genes are linked. Some of y'all put the genes are linked but not very tightly because crossing over happens. These genes are pretty tightly linked because crossing over happens approximately 10% of the time. All right, last up, we got bedbugs. This is similar to, again, question number 4. Actually, let me go back here real quick. This is not College Board formatting. These are College Board questions, but breaking it up into 7 parts is not what they do. I just did that to make it easier on the form, but there's no such thing as a 7-point FRQ, and the College Board like bolds their prompts, like action verbs in their prompts. So you probably noticed that, but it's based on something real and important. It just doesn't like look the same way. Bed bugs. All right, so basically what these scientists are saying is that there's 5 strains of bed bugs, and they think that these genes help the bed bugs survive insecticides. And if you look, when all those genes were intact in the wild type fly, the survival rate was greater. But then you got to look at these error bars. And so the error bars communicate confidence or statistical significance. And the first part of this question is pretty easy. And then the second part, you're like, what? I mean, they're talking about enzymes that detoxify. They're talking about transporter proteins. They're talking about exoskeleton. And it's hard to know what to do with that. So I'm going to show you the answers. For part A, strain 1 is a control. You get 1 point for that. Then you get 1 point for saying the error bars for the control and strain 3 do not overlap. You could also say, instead of that, you could say there is a statistically significant number of more bed bugs surviving when ABCA was not deleted. So either one. Don't have to have both of those, but that's part A. Part B looks like this. Strain 5, in which ABC8 and P450 were deleted, shows a lower survival percentage when compared to strain 4, in which CPS was deleted. Most of you guys got that. Like, you were able to come up with that, but then the explanation, kind of tricky, y'all. We got many answers from our class that I noticed talking about the function, because we got 3 deletions in those genes. One of them's like a membrane protein that pumps the toxin out. One of them's like an enzyme that breaks up the toxin. And then the third one's like a component of the exoskeleton that blocks entry. So these 3 genes, they're studying, and basically they're saying, why did more bed bugs survive when these 2 were intact versus deleted? And most of you had answers like, well, this one just blocks the entry, whereas these 2, number 1, there's 2 of them, these 2 actually chemically change the toxin or actively remove it from the cells. And so that was tempting, but the answer doesn't come in describing the function of those, and I feel like that was tricky. The answer just comes by saying bugs in strain 5, the ones in which those 2 genes were deleted, can't do what the genes would allow them to do, while bugs in strain 4 can do it. So simpler than maybe you thought. I hope this was helpful. Getting kind of long here. I can totally ditch this voice. I don't know if I can do a different one. Thank you for your patience, and we'll be in touch next week. Bye, y'all.